Today we're going to interpret the meaning of values in functions. So reminder that when we are looking at exponential equations, exponential functions, b in this particular expression here is your base, and the a value here is your initial value, okay? Also your y-intercept. So let's talk. When we have something like this first example here, an exponential function models the population of a small town. So we've got that p is equal to 14,512 times 1.03 to the t. And t is time. Oftentimes exponential function represents time, which would be your x variable, your independent variable. And it's the number of years after 2005. So remember that initial value, your y-intercept, is your number out front of the base. All right, so we've got 14,512 people. Okay, these are people in 2005, right? Because that's when we're starting. And this function is either increasing or decreasing based on a base. Now reminder, if you are increasing, your base is going to be greater than 1. If you are decreasing, your base would be less than 1. So we are increasing here because our rate here, right, where our base is greater than 1, and the rate is the percentage now of when I either add or subtract 1 from this number. So when we're greater than 1, we're wanting to subtract 1 now. So if I have 1.03 and I take away 1, we're left with 0.03. But remember, we want percentages here. And so what we're going to do is multiply by 100 now. Okay, when we change a decimal to a percent, we divide by 100 because that's what percent means. But if I want to know what percent a decimal is, we multiply by 100. And we can see that 0.03 is equal to 3%. We'll do 0.03 times 100 is 3. So the rate here is 3%. And what this means is that this population is increasing 3% every year. Okay, so we're going to say the population of 14,512 people is increasing by 3% each year. All right, so again, when that number is greater than 1, you have an increase. When those numbers are less than 1, we have a decrease. So let's talk about that. John's new Mercedes-Benz value can be represented with equation P equals 75,000 times 0.8 to the t. Again, t is the number of years. 75,000 is the initial value, okay? The cost of the new car, okay? It's the cost of the new car. All right, and because this number here, 0.8, is less than 1, the value of that car then is decreasing. Now, just like when the number was greater than 1, we subtracted from 1, from here, we are going to we also want to subtract from 1, all right? I'm sorry. Yes. So we're going to do 1 minus 0.8. Okay. And we can get 0.2. Okay. And then we're going to take that 0.2 and multiply by 100. To see that our rate here is 20%. Okay, so for this example, we're talking about the value, all right, of this Mercedes-Benz, which starts at $75,000 and then decreases at 20% each year, okay, which is exactly what we're going to write for the interpretation. The initial value of the Mercedes-Benz of $75,000 decreases by 20% each year. I'll have you complete the other examples and the rest of your packet.